Hey everyone, I'm Matt. Welcome to my garage. Now this week we're going to be chasing down some energy hogs here in my house and seeing if we can use some home automation tricks to try and reduce my energy usage and realize some actual dollar savings in my monthly electric bill. Now when we bought this house last year, I installed an Emporia View energy monitoring system, and I'll put a link to one of those in the video description in case you guys want to kind of duplicate what it is that I'm doing here. But basically it's a pretty simple to install device. I got a 16 channel one. Basically you just install some current transformers over each individual wire coming out of each breaker for each circuit that you want to monitor, as well as some CTs on the mains, and then you just have to wire nut in some power to it. It's pretty easy for a DIY kind of a project. Now, I love all the data that I get from this Emporia View. I mean, it's what allows me to make decisions on where to chase down some cost savings. It tells me where my electricity is actually being used. Now, I'm not going to take the panel cover off here because, to be honest with you, it's kind of a mess inside of there and everything's sort of crammed in there. And if I take this off, the wires are going to kind of dangle out. I'm going to have to shoehorn it all back in there. But unfortunately, the previous owners here, they installed 400 amp service outside, and when they did, they moved the box to a surface mount, and then they had this little tiny chintzy looking chase over the top of where all the wires were coming out of the top of the breaker box. I got rid of all that. I built out this this drywall cover here, which looks much better. Covers all the wires and actually blends in with the wall instead of being the big mess that it was. And then I 3D printed this cover. This is where the actual Emporia View unit is. It connects via Wi-Fi to my home network, and that way I can download data or view real-time data right on the app on my phone or my iPad. And you'll see here I've just printed out a list of the circuit designators here. The ones that are highlighted in the yellow highlighter color, those are the circuits I'm actually monitoring with the View. And I haven't permanently made labels for this yet. I will. But I've been moving the current transformers around and downloading data once a month so I can see where my power is actually being used. So these actually change from month to month. If you guys have been watching my recent videos, you'll know that a couple of months ago, I installed a new water heater. Now, the first month after I started monitoring my power usage with that Emporia View, it became obvious that my water heater was far and away the biggest consumer of power in my house. It was using right at 15 kilowatt hours per day. And we pay 15 cents per kilowatt hour, 14.7 I think. And so at 15 cents per kilowatt hour, 15 kilowatt hours per day, that amounts to, like $2.25 or something like that. So pretty significant cost, I mean, you might think $2.25 is not that much money, but it's 7 days a week, 365 days a year. That's a pretty significant amount of money. So I did some research and determined that a heat pump water heater would use roughly 1/3 of the power of our conventional water heater, and I installed that. Did a video on it. You guys can watch it if you want. Pretty straightforward install. And the data is really telling. I mean, we've had it installed for a few months now, and it's steadied out at about between 4 and 5 kilowatt hours per day. I think 4.4, somewhere around there. So it's using less than 1/3 of the power that our old water heater was using, to the tune of about 60 cents per day. So the difference between 60 cents and $2.25 a day is massive. This thing will pay for itself in right at 3 years, just a little over 3 years. It'll pay for the purchase price and installation and everything, and then everything beyond those 3 years is savings. Now, I was able to make that decision because of the data that I gathered from the Emporia View home energy monitoring system. So pretty neat stuff. Now, I don't have any more big wins to gain at this point. I mean, I've already gone after as much energy efficiency as I can in the house. I've replaced every light with LED bulbs, and I've put all of my exterior lights on smart switches, and I set those up on a routine. And so they come on at sunset and go back off again at sunrise every single day. And that changes from day to day, obviously. And that way I don't have to have a bunch of different photocells to control those. It's all done through my smart hub. And anyway, long story short, I don't think that there's any more big energy savings to gain. I did consider my dryer because that's another big consumer of electricity, but even though it uses a lot of power when it's running, we don't run it that often, and so it's only costing us a few dollars a month to run. And even if I was to buy a more efficient heat pump clothes dryer, the payback period, I would likely never realize it. I mean, the payback period would be something like 20 years, and the dryer itself just wouldn't last that long. So no more big purchases or anything to go after energy efficiency. What we're gonna do today is chase down some of my always-on devices, figure out how much power they're using, and do some rough calculations to decide really how long do I need them on during the day and how much savings could I get if I reduce the amount of hours that they're actually powered up every single day. All right, I have the Emporia View app running here on my iPad. Look at those hexagons, neat. I will screenshot this and place it somewhere in the corner of the video so you guys can actually see what I'm seeing as we're doing this. We're gonna start out here in the garage. And basically I'm just gonna look around and see, hey, what do we have plugged in? Nothing plugged in over there. I do have stuff plugged in here, my freezer and my home theater setup for my workout area. And then I've got a couple of things plugged in here. I do already have my cold plunge on a smart switch right here because I don't like running it all the time, and it draws quite a bit of power, and it only needs an hour or so to cool down in the morning. So not gaining anything there because I'm already as efficient as possible. The other thing is the heater for our sauna. It doesn't take any power when it's in the standby mode, so nothing to gain there. Now there is something to gain right here. Now the way that I use that home theater setup in the morning, sometime between 6 and 8 in the morning, I'll do my cold plunge, and then I'll do a strength or a calisthenics workout, and I use that home theater setup to follow along with whatever program it is that I'm doing on YouTube or whatever. And so it needs to be on in the morning, and then if we sauna at night, the portable sauna gets set up here, and then that gets run during the sauna time for an hour or two at night. So yeah, this is on all the time, but it doesn't need to be. It only needs to be on for an hour or two each day, and I could easily set that up with a timer. So let's see how much power it's using. There we go. So we can see we're using about 77 watts. All right, let's unplug the subwoofer, see how much power that's using. 77 down to 70 watts. So it's using roughly 7 watts when it's in standby. Plug that back in. Now there was an initial spike, but it's back up. So it uses about 7 watts, the subwoofer does. Now let's unplug the receiver. There it goes. That's a big one. So 77 down to 26. We'll say that's 50 watts right there. That's 50 watts that's being used just by having that receiver turned on. That's a big one. I have a feeling we're gonna be going after that one. All right, plug that back in. There we go, back up to full power. Okay, if we want, we can look at the freezer and see what it's used. Give me just a second on the app here. We can go garage freezer, and let's look at it on a weekly basis. It's using about 1.8 kilowatt hours per day, you can see. That's just not much. I mean, we'll just round that up to 2 kilowatt hours per day, so it's using about 30 cents per day. There's no savings to be had there, really. I mean, it adds up, but I can't really do anything about how much power it takes to run, so. All right, let's move into the house. Here in the kitchen, we could look at what's plugged in, but I don't really think there's gonna be a whole lot of savings. I already know that the coffee pot and the Instant Hot, they don't take any power when they're in standby, and they auto off. So what's taking power here? Oh, probably this. Yep. So my under cabinet lighting was actually taking 50 watts. That's we're not going to go after that today, but that is something to consider. 50 watts is actually quite a bit. These are old fluorescent lights, and some of them aren't even working. So maybe I will look at that in the future. But these draw so little power that they're essentially negligible. They're essentially zero. So nothing else here in the kitchen. But here's one that I think we're almost certainly going to go after. Let's switch up to this one here. So this circuit has 227 watts on it right now. I know that this fan is part of that. Let's unplug this fan and see. So that's, you know, about 45 watts right there. 45 watts is pretty significant. You plug that back in. Now, how do we use this fan? Well, essentially, in order to keep our heat pump from running, we have a fire going in our fireplace 24/7 almost. That keeps temperature in the house up in the low 70s, high 60s, except during the coldest days. And that fan runs all winter long. But the thing is, we really don't need it running during the night or really during the middle of the day, really just in the mornings and the evenings. So it does help. It's super nice to circulate the hot air, but I think that's a spot where we can gain some energy efficiency. Let's go over here to our plugins for our vacuum battery and for our robot vacuum. 235, and plug those. Really pretty negligible, less than 10 watts. I wonder how much a Glade plug-in takes. I suspect it's only a few watts, but let's take a look. Yeah, I mean, a couple of watts at most. That's not going to make any difference. Let's unplug this subwoofer here at the home theater system and see if that makes any difference. Oh, it does. 5 watts or so. Yeah, so the subwoofer is 5 watts. I know that this thing has an auto off feature to it, so in standby mode, that's what it draws, is around 5 watts. Not really a whole lot of power. I'm not too worried about that. I do have a massive battery backup right here. Let me see. I need to figure out which one is the receiver. So I have a power strip in here that powers the Chromecast, the Blu-ray player, and I've got a Retro Pi in here for doing vintage gaming. So if we kill the power strip, that's what it's going to kill. Let's reach back in here and see if we can figure this out. So we're starting at 227 watts. This kills that power strip. Not terribly significant. Let's unplug our TV. Yeah, again, just not very significant. I think most of these things, when they're in standby mode, are pretty power efficient. All right, and then let's unplug the receiver. That's going to be our last thing here. All right, 253. Wow. That receiver is drawing 100 watts. Okay, I'm not going to go any further because I have found the culprits that I want to go after. And that's going to be the receiver out in the workout area, this fan right here, and then the receiver there for the home theater system. And so if I install some smart outlets on those and set those up on timers, I should be able to easily meet my goal of saving an average of 100 watts for 24 hours a day, which would be 2.4 kilowatt hours per day. So what I'm going to be using are these Third Reality Zigbee smart outlets here. I do have a Hubitat home hub, so this is what will connect these to the internet and to the rest of my smart home. I think you'll notice one's missing. It's because I'm using it for temporary lighting out in my shop. So we're just going to be using these 3 here. These also, I believe, have actual energy monitoring features in them, so we can actually see how many watts are being used when they're turned on. So I'm going to go ahead and pair these with my Hubitat, and then set them up inside of my home automation system and put them on some schedules. Okay, adding these devices is pretty simple. You can see inside of my Hubitat user interface here. I'll just click on the add device. We're going to add a Zigbee device, and I'm going to start Zigbee pairing and plug this thing in. So it says give my new device a name, and we're going to call this the garage receiver. Next. Oh, I don't have the room there. Let's go back to our device list. Okay, now garage receiver. Now that we've got it installed, you can see it here. We have off and on. Let's try this. Okay, we heard it click, and I can see the light on, off, toggle. Okay, so we've got this one installed. This is going to be for our garage receiver. Now we're going to do the same thing for the other 2 outlets. All right, this is our fireplace fan one. Let's plug it in right here. All right, not to worry if the smart feature doesn't work. It's always got the button on the side, so you can turn the fan on and off that way. Let's go ahead and install the garage receiver one out in the garage. All right, let's try these out. We have the garage receiver. Right now that's off. Nice. Okay, that works. Let's try the fireplace fan. All right, that works as well. Let's try the home theater receiver as well. Ooh, interesting. How's that not working? Oh, it says it's offline. All right, got a little bit of troubleshooting to do. It might be just as simple as being behind that right there. Zigbee, it operates on a higher frequency than Z-Wave devices, and it might be that it's not getting a good signal from the hub. I would think though that it would repeat from room to room, but I'm gonna sort that out. All right, just a little bit of troubleshooting. I just determined that the placement of that Zigbee device wasn't ideal for receiving signals from the hub. It's kind of unfortunate. The Zigbee devices just, they operate on a higher frequency, and physical barriers tend to affect them more than the Z-Wave devices do. So what I did is I already had a power strip in here that I had other stuff plugged into. So I moved the smart outlet up to that power strip and plugged the receiver into that. And that has solved my problem, because now, like now I'm on, I can hit the off button and it shuts everything down. So all 3 of my smart switches are now functioning. Let's see how much power we save with all 3 of those off and how much power we use with all 3 of them on. Synchronizing in 3, 2, 1, now. All right, so this is our total usage since I'm going over basically 3 different circuits, but so we're at about 1560 watts right now. I'll put this over the lower right-hand corner. Let's turn all 3 of these things on and then turn them off. So our home theater receiver is on, fireplace fan is on, and the garage receiver is on. All right, so with all of those on, we're about, there's going to be some fluctuations because right now we're looking at the mains, so our data isn't quite as granular as the smaller current transformers are, but whatever, we're around 1600 watts, and we can see our line right here. Let's turn all three of these off. So fireplace fan off, garage receiver off, and home theater receiver off. Look at that beautiful step down right there. Okay, with all three of those things off, we're saving nearly 200 watts. And those were things that were on all the time before. Obviously, they're not going to be able to be off 24/7. We use that stuff sometimes. So what I'm going to do is I'm going to set up some timers for those. I'm going to think about when we most often use those and just make sure they're on during those times. So now that we know how much power we're saving, let's port these through to my smart home system. For this, I'm going to add these to the Amazon Echo skill. These are all switches and things I've already got on there, but see, now I need to add fireplace fan, garage receiver, and home theater receiver. And we'll update that. Hit the done button. Now with these added to the Amazon Echo skill, I can control these with any of my Echo devices verbally, and then I can also set my timing there. I can do the timing inside of the Hubitat app as well, but I like to keep, I kind of consider that the back end, and so I like to do all my timing and scheduling if I can inside of the Amazon app. So let's try this out. Alexa, turn on the fireplace fan.
Okay.
Hey, it works. Alexa, turn on the garage receiver.
Okay.
All right. Alexa, turn on the home theater receiver.
Okay.
Okay, task complete. Let's set up schedules for these. See, it says 3 new devices connected. That's these right here. Here they are. Okay, so we're going to start with a fireplace fan. We're going to create a routine. Repeat every day at time 5:00 a.m. Right, I'm going to take a few minutes to finish typing in the rest of these routines. All right, I have all my routines added here. So what I've got is the workout area, the garage receiver. It turns on at 7 p.m. and off at 10 p.m. That is for the sauna time. The receiver turns on at 8 a.m. and off at 10 a.m. That's for the cold plunge and workout time. The home theater receiver is on at 5 p.m. and off at 11 p.m. That's basically the only time that the TV is ever on. So, and then the fireplace fan, we have it running from 5 a.m. to 9 a.m. So basically when we get up, and then 5 p.m. to 10 p.m. So when we might be in the kitchen and around the house. So that'll put all these on a schedule. You can see I've got some other routines here, just to turns my shop lights off just in case I forget to do that, things like that. There's my sunrise and sunset ones. I think for this watch TV, I might add another action. Plugs, home theater receiver, we'll turn that on. Now you might ask, why not just remember to turn these things on? Well, it's a matter of convenience. It's not just me that uses these, and so I want this to be essentially seamless. I don't want there to have to be, to remember to turn things on and off. So by putting it on a schedule, when I already know that we use these things, it's kind of a seamless transition. It's no more user input is needed, and it just happens automatically. You don't have to remember to turn things on or off. It just does it. And I think that's going to work pretty well for us. So now that all of our routines are set up and I know exactly how many minutes each one of these devices is going to be running during the day, let's go plug all this into a spreadsheet, see how much money we're going to save. All right, sitting down in my office here, back at the computer, I'm doing some nerd stuff. I've made up this Excel spreadsheet. I will share this in a screenshot and go through it with you guys, and we'll crunch some numbers. All right, just took a few minutes to draw up this spreadsheet right here. And it's pretty basic, should be fairly self-explanatory. This first line is just a header. And then I've got numbers for the garage receiver, for the fireplace fan, for the home theater receiver, and then totals underneath that. And my columns here, this is how much power each of these draws when they're powered on but idle. This is how much they were drawing when they were just on all the time. So you can see the garage receiver is about 50 watts. Fireplace fans 45, and the home theater receiver was 100 watts. So pretty power hungry thing to just sit there and not be used. So the number of kilowatt hours used in 24 hours, 1.2, 1.08, 2.4. Number of hours now that I have it on a schedule. This is on for 5 hours during the day, 9 hours, and 6 hours. And this is the adjusted kilowatt hours that are going to be used now that it's on a schedule. So you can see we went from 1.2 when it was on for 24 hours a day down to 0.25 when it's on that 5-hour schedule. So these are our calculated costs. So when it was on for 24 hours a day, we were using 18 cents, 16 cents, and 36 cents. So 70 cents per day total. You guys may not think that's much, but wait till you look at the long-term effects here. So how many dollars per day are we using now that we're on the schedule? That's 4 cents, 6 cents, and 9 cents. So while we were on 24 hours, we were spending $5.40 per month, $4.86, and $10.80 all per month when the things were on 24 hours. Now that we're on a schedule, those same things are costing us $1.13, $1.82, and $2.70. This is how much this was costing us per year for each of those devices while they were on all the time. $65.70, $59.13, and $131.40. Now that we're on a schedule, $13.69, $22.17, and $32.85. And some basic subtraction, and these are our cost savings. So $52.01, $36.96, and $98.55. So that works out to a savings of $187.52, and that's just for the couple of hours of tinkering around that I did today. Pretty significant savings, and it's almost 200 bucks. And that assumes that our cost remains at 15 cents per kilowatt hour. I added that as a variable in there. I'm going to just save this spreadsheet and use it for other devices that I might decide to throw on a schedule. So, all right, guys. That really wraps up this project, and I know it's kind of a lengthy one for such a simple, basic thing, but I find this stuff really interesting. Hope you guys did too. Thanks for watching, and we'll catch you on the next video.